Hello everyone, this is problem 7 in problem set 6.3. In this problem, they give you the demand function of 29.85 minus 0.03 p squared with the unit of million units. So in part A, they ask you to calculate the price at which the consumer will no longer purchase the item. To do this problem, we have to think about this a little bit. We have to think that there will be no more demand when the price is too high, right? So we want to look for the value of P such that the demand is 0, right? So you're going to set the demand function equal to 0 using the solver. You can calculate the value of P. So that is 29.85 minus 0.03 p squared equal to 0. And the value of P is $31.54. So at the price of $31.54, the consumer will no longer buy the item. That's part A. Now let's move on to part B. In part B, they ask you to calculate or compute D of 5 and integrate to what you got from the calculation. And you want to calculate the quantity demanded at the price of $5. That is D of 5 equal to 29.85 minus 0.03 times 5 squared. And use a calculator, you could be able to get the quantity demanded value. So from a calculator, you could be able to calculate the quantity demanded at the price of $5. That is 29.1 million items. Why do I have million items or units? Because the unit is million units given by the problem for the demand function. And then let's integrate what we got from here. So at the price of $5 per item, the quantity demanded by the consumer is 29.1 million units. So now that is part B. Now let's move on to part C. In part C, they ask you to compute the consumer expenditure at the price of P equal to $15. This is the set market price. As you know, the consumer expenditure is equal to the set market price multiplied with the quantity demanded at that price. So that means you have the set market price 15 multiplied with the quantity demanded at this price. That is D of 15. So we need to calculate this value, D of 15, and you know how to do that. So D15 is equal to 29.85 minus 0.03 times 15 squared. So the quantity demanded is equal to 23.1 million units. We're going to substitute 23.1 into the consumer expenditure formula right here. So that is 15 multiplied with 23.1. And using the calculator, I got $346.5 million. That is part C. Now let's move on to part D. In part D, they want you to calculate the consumer surplus at the price of $15. That is the set market price. The consumer surplus is equal to the integral from the set market price, which is $15, to a Pmax. In this case, I'm going to use Pmax. Why is that the case? First of all, we are not dealing with exponential functions. And second, if you look back in part A, they ask you to calculate the price at which there will be no more demand. So you have Pmax equal to 31.54 of the demand function D of P dP. And this is the definite integral from 15 to 31.54 of 29.85 minus 0.03 p squared dP. Because this is just definite integral, you can use the option math 9 to get the value of 213.72, and the unit once again is million dollars, and that is the consumer surplus. In part A, they ask you to calculate the price at which the demand is 10 million units. So that means you're going to set the demand function equal to 10, use a solver to get the value of P. So that is 29.85 minus 0.03 P squared equal to 10. And from here, you could be able to get the value of P. Using a solver, I could be able to get the value of P equal to $25.72. And that is the answer for part A. And we just finished problem 7 in the problem set 6.3. Please let me know if you have any questions.